distance. So what distance are we calculating? PQ. We are calculating PQ. Is it along the parallel latitude or along the longitude? Since it's along, is in the west, along the west, automatically that will be what? Longitude. Since our longitude is west-east, so it's along the longitude. So if it's distance along the longitude, distance along the longitude of the great circle is going to be theta over 360 times 2 pi capital R, where R is the radius of the earth, which has been given to what? 7,000 kilometers. So here our distance equals, what is our theta? Our theta is 60 over 360 times 2 times 22 over 7 times 7,000. So here 0 can cancel 0. 6 here 1, 6 here 6. 2 here 1, 2 here 3. Then we have 7 here 1, 7 here 1,000. So 22 divided by 22 times 1,000, that is 22,000. So 22,000 over 3 kilometers. That is our distance. So we go to our option and see the one that matches that. And that will be no other option. Our option what? C. Now, question 22. 2 points P and Q are on Earth's surface. Find distance between PQ. So this one is also longitude and latitude. If you check the objectives of the UTMA concerning measuration, we discover that anytime they want to test longitude and latitude, it will always be what? Distance. Take note of that. That is why our attention is centered on what? Calculating distances. So in this situation, 2 points P 32 degree north, 47 degree west, and Q 32 degree north, 28 degree east. In this situation, you can see that the latitude are the same. So in this situation, let's draw our great circle where we produce it. This is our Greenwich meridian, 0 degree south here, 0 degree north here. Then let's produce our equator, which is 0 degree east, 0 degree west. So in this situation, our P is 32 degree north. So it will be towards this direction. So this is 32 degree north. Then we have 47 degree west. 47 degree west. So let's say these are 47 degree west. So the point here is what? The point here is point what? P. Then our Q is also the same latitude. That's the same latitude, 32 degree north, but this time around 28 degree east. 28 degree east. So it will be something like that, and the point will be, point Q will now be here. So that is 28 degree east. So if we have to determine that, so all we just need to do is to just carve out a point here. So, and it will be looking like this. Looking like this. Meanwhile, this is our P and this is our Q. Now, what is here? Because this place is alternate to this place. So this place is alternate to this place. So what's here? 47. So this place is 47 degrees. And what is here? This place is alternate to this place. So what is here? 28. So 28 is here. Automatically 28 will be here. So that means our theta, which is the whole of this place, will be 47 plus 28. So that will be what? 8 plus 7, 5, and that's 75 degrees. Now, our distance. If you look at this now, PQ is what? It's along the parallel of latitude. Take note, the one we saw previously, that one was on the longitude. But this time around, this one is on the parallel of latitude. So it's really what? Small r. So the distance along PQ, which is equals to parallel of latitude, parallel of latitude of lat, will definitely be what? D will be theta over 360 times 2 pi small r this time around. Take note, because it's along what? The parallel of latitude. And you know from your previous knowledge that r is equals to capital R cos alpha, where our alpha is the what? Latitude. Remember this. So that means anywhere I come across r, I will replace it with what? Capital R cos alpha. So if I go back to my original formula, it will now be d to be equals to what? Theta over 360 times 2 pi capital R cos alpha. That's cost of latitude. Now, what is our theta? Our theta is 75. So distance 75 degrees over 360 degrees times what is our, so 2 times pi. Let's say, okay, it has been given, that is 3.142. That's our pi. Times r, what's the radius of the hertz? That's 6,400. Times cos of latitude. What's the cos of latitude? Our latitude is what? 32. Cos 32 degrees. So that is the way we are to go about. So let's use our mathematical calculator to fashion out the answers here. The answer here. So that's 75 times 2 times 3.142 times 6,400 times cos 32 divided by 360. So let's do it one by one so that we don't miss the answer. That's cos 32. Cos 32 is times 6,400 times 3.142 times 2 times 75 divided by 360. So that will be, distance now will be 7,105.5 kilometers, which is the answer for this particular question. And the last question under this topic, measuration, is 23. That is, an arc sustains angle 50 degrees at the center of the circle of radius 6 cm. Calculate the area of the sector. See, this one we have been solving questions like this, times without numbers, so they are not new. So in this situation, you have what is question of calculate the area of the sector. What's the formula for calculate the area of the sector? It's theta over 360 times pi r squared. In this regard, our r has been given to the what? 6 cm. Our theta has been given to the what? 50 degrees. What else? Our pi is 22 over 7. Then here our area will now be 50 over 360 times 22 over 7 times 6 times 6, because we have r squared. So that's 6 squared, which is 6 times 6. In this situation, I have 6 here 1, 6 here 60, 6 here 1, 6 here 10, 10 here 1, 10 here 5. Then I have 5 times 2, 22. That is 5 times 2, 0, 1. 5 times this, 10, 1, 1, 1, 1, 0 over 7. That is centimeter squared. So 110 over 7 centimeter squared. That will definitely be option D. Our next topic is local, which is the plural of locus. Under this topic, candidates should be able to identify and interpret local relating to parallel lines, perpendicular bisectors, angle bisectors, and circles. Remember that in our previous lessons, we ought to have treated construction extensively. So here, what is a locus? A locus is a collection of varying positions which describe where an object is located. There are 4 points under this locus. The first one is the locus of points at a given distance from another given fixed point. Take note, this locus is a circle whose radius is the given distance and its center is the given fixed point. So take note of that. Each time you are tested on that, you know what it is all about. Then 2, locus of points at a given distance from a straight line. This locus is the set of 2 parallel lines on opposite sides of the given straight line, each at the given distance to the original line itself. Then point 3,